I hope you had a little fun with the Ken puzzles. Again, I love those things, and they are a perfect example of what deductive reasoning is. What you're going to find is that deductive reasoning is you have to draw conclusions based on certain information that you're given within a situation, some constraints. And what you may have noticed is that there is only one way to solve the puzzle correctly. All right. And you can't always fill in a square that you want to fill in. Sometimes you have to go to other squares first and fill those in. And so, again, as we go through this and learn about what deductive reasoning really is, think back to the Ken example and notice how that puzzle relates to what we are going to be learning here. So let us share our whiteboard and proceed. So deductive reasoning. What I want to do to start is just remind you about what, before we talk about what deductive reasoning is, I'll remind you what inductive. Oh, I need to close that Grammarly again. Inductive reasoning. Let me pause. Okay, inductive reasoning. So again, what is inductive reasoning? Basically, you are drawing conclusions based on observations or perhaps patterns that you notice. But the thing about inductive reasoning is that the results that you come up with are not certain. It's sort of like an educated guess, right? It's an educated guess based on some sort of pattern. For example, I could say if a student is continuously late for class, it's likely they will be late for the next class. Well, that may be true, but they may be on time. It doesn't guarantee that they'll be late for the next class. It's just a pattern that I've observed. So to help us get acquainted with what deductive reasoning is, I'm going to give you a little scenario, and I will do a little copy and paste. So again, it's nice and clear text for you. Okay, so here is the scenario. A middle school theater program is putting on a play. However, some of the students don't get along, typical middle schoolers, right? Now, there are 4 bullet points that you have to consider. Mike won't participate in the play if Cynthia is in it. Tim will only participate if Cynthia is in it. If Mike participates, Jemiah refuses to join. So, if the director needs 1 male and 1 female in the play, who will be chosen? All right. Go ahead and pause the video and see if you can solve this problem. See if you can figure this out. I will keep going. So there are some things that we need to consider. The first is that if Mike is chosen, so let's kind of say, let's pretend if Mike is chosen, then what does that mean? It means Mike will participate in the play if Cynthia is in it. So if Mike is chosen, that basically means no Cynthia. Okay, so let's just pretend for a second that we're going to say, yeah, Mike's in. Well, that means Cynthia couldn't be in, right? But then if we read this third bullet point, it says if Mike participates, Jemiah refuses to join. So no Jemiah. All right. Well, if the director needs 1 male and 1 female, Cynthia and Jemiah, those are our females. And so if Mike's in, then we don't have a female to participate. So what does that mean? It means Mike can't be in. Because if Mike's in, then neither of the females are in. Okay. So if Mike's not in, we only have 1 other male. We only have 1 other male. And that would mean that Tim would be the male. Okay, so can we figure out which female would be in? Well, this second bullet point says Tim will only participate if Cynthia is in. Okay, well, the only way Tim will participate is if Cynthia is participating. So that means that who will be chosen? Tim and Cynthia, because no other combination of students would work given this information, right? Given that original information. What we just did there was a process of deductive reasoning. So let me type out how we might define deductive reasoning. Deductive reasoning is where given premises lead to a definitive conclusion. Where given premises lead to a definitive conclusion. So what are premises then? A premise is a statement or proposition assumed to be true from which another is inferred or follows as a conclusion. Inferred, I type a V and an F. Okay, a premise is a statement or proposition assumed to be true from which another is inferred or follows as a conclusion. So these pieces of information here, Mike won't participate in the play if Cynthia is in, Tim will only go if Cynthia's in it. If Mike participates, Jemai refuses, and the director needs one male and one female. Those are the premises, right? They're these given pieces of information that are assumed to be true for this scenario. We then use deductive reasoning, which means using all the information up here. We can't ignore any of it, and we have to draw some conclusion for who will be chosen. And we found out that would be Tim and Cynthia. All right, so how do we do this then? I just gave you this example where we kind of just talked through it, right? But there are some other strategies we can use to solve problems using deductive reasoning. One of which is Venn diagrams, right? Our old friend of Venn diagram. We use these back in section 2.1 to analyze and diagram sets, but we can also use them to draw conclusions using deductive reasoning. So I'm going to give you an example here, showing you how to use Venn diagrams. And we're going to start with two premises. The first is all humpbacks are whales. And the second is all whales are mammals. All right. All humpbacks are whales. All whales are mammals. So what conclusion can you draw? And let's use some Venn diagrams, our good old friend, the Venn diagram. So one thing, if I just look at premise number one, and I look at this premise, all humpbacks are whales. Well, let me actually do it like this. Rather than start with that, I'm just going to draw a big circle. And I'm going to say this circle is all whales. Well, if all humpbacks are whales, that means that humpbacks are a subset of whales, right? So every single humpback is also a whale. Okay, so that shows that initial premise. All humpbacks are whales. Well, now I'm going to look at the second premise. All whales are mammals. Okay, so if here are all my mammals, whales are a subset of mammals. Every single whale is a mammal. There are other mammals that exist that are not whales, but every single whale is a mammal. So that's our second premise. If we now combine these two things, what you're going to see is we will have So if I do put my rectangle out here, and we'll start with mammals. Inside mammals are all of our whales. And inside whales are all of our humpbacks. So the question is, what conclusion that can we draw? Well, all of our humpbacks exist in here, inside whales, which is inside mammals. So could we then conclude that all humpbacks are also mammals? Absolutely. What conclusion can you draw? All humpbacks are mammals. There we go. That is a valid conclusion. And we showed that using some Venn diagrams and the idea of a subset. Now, maybe you already knew that all humpbacks were whales and therefore mammals. Maybe you didn't. One of the nice things about using deductive reasoning is that you don't have to know anything about the subject matter to draw a logical conclusion. So I'm going to give you another one. I'm going to give you another scenario with these premises. All salamanders are amphibians. Animals with amnions are not amphibians. What conclusion can you draw? So go ahead and pause the video for a moment and see if you can figure this out. What conclusion can you draw given these premises? I'll keep going. What you may have come up with, if you used a Venn diagram, was something that looked like this. I will just copy and paste rather than draw it myself. We stated initially that all salamanders are amphibians, which means that there's this group of amphibians and salamanders are a subset of them. It also says animals with amnions are not amphibians. So you've got this other group of animals over here with amnions. We don't even know what that is, but they're not amphibians. So they're separate from amphibians. So what conclusion did you draw? Because salamanders are a subset of amphibians, but animals with amnions are completely separate from amphibians, we could say, we could draw a conclusion that salamanders do not have or develop amnions. They can't. They exist only in here and they can't go over there. And again, we don't even maybe know what that means. Maybe you do, maybe you don't. But we don't have to know the information in order to use deductive reasoning. Now, the language that we use in deductive reasoning and the premises and the conclusions that we draw, the language is very important. We have to understand this really carefully and be really cautious with certain words. So let's talk about the word some. S-O-M-E. When we use the word some, that means at least one. At least one. It could mean many, but it means at least one. And so when we have a Venn diagram, that there's at least one element and we're using two different sets, what we're going to do is we're going to use a dot, right? We're going to use a dot to show like where we know there's at least one element if there's overlapping regions of two sets. So let's look at an example of what I mean here. Here's another situation. So I'm going to let you read this. So the premises say, one, all custom officials are government employees. And two, some college graduates are custom officials. What conclusion can you draw? All right. So we need to be extra careful here. So again, I'm going to do a little copying and pasting so we can do this neatly. The first thing we might see or might notice, government employees and custom officials. All custom officials are government employees. So customs officials is a subset of government employees. Okay. The second premise, if we put it into a Venn diagram, might look something like this. We have customs officials, but it says some college graduates are customs officials. It doesn't say all college graduates, right? College graduates is not a subset of customs officials, but we know that there's at least one college graduate who is also a customs official. So we would represent that with a Venn diagram like this. You've got an inner overlapping circles, and you've got at least one dot in that intersection point. Now, if we merge these two together, what we'll end up with is a diagram that looks like this. Our government employees circle is out there. Our customs official is a subset. But then we have this blue circle here of college graduates. There's a dot inside the customs officials. But notice how I've got X's there. What do those X's mean? It means that there may be elements there. There may be college graduates who are government employees, but not customs officials. And there may be college graduates who are not government employees, but we can't know that for sure just based on this information. You have to pretend like that's the only information that you have in the world to make any conclusions with. So this is what our Venn diagram would look like. So what's the conclusion then that we can draw? We can state that some college graduates are government employees. Because some college graduates were customs officials, that means there's at least one that also exists within the government employees group. But that's the only conclusion that we can draw. And this introduces the idea of invalid reasoning. We want to make sure that we are using valid reasoning. Invalid reasoning would be drawing conclusions that you can't make based on the information that was given. If you drew a conclusion and said, well, I know that there must be a college graduate there, that would be invalid. We would not be able to say that. No conclusions can be drawn about college graduates outside the government employee set or the government employees outside the customs official set. Okay. Our conclusion, this is valid. Okay. We didn't assume anything that was not in the premises. So using kind of extending that idea, what I'm going to have you do then is I'm going to give you a couple premises and then make a conclusion. And your job is to examine that conclusion and say, is this conclusion valid or not? Or is it invalid? So here are two premises. Some members of the Appropriations Committee are Republicans. Some Republicans are members of the Ethics Committee. So let's say somebody drew this conclusion. Some members of the Appropriations Committee are members of the ethics committee. So your job is to determine, what do you think about that? Is that valid or invalid? Valid or invalid? And use a diagram to help you make sense of this. Go ahead and pause the video and work this through on your own. So let's see what's happening here. What we have are three different groups: the Appropriations Committee, the Ethics Committee, and Republicans. If we start with a circle here and we say this is the Appropriations Committee, so members of the I'll abbreviate that, APP, Appropriations Committee, okay? And we know that some members of the Appropriations Committee are Republicans, not all of them, so we can't make Republicans a subset, right? There has to be some overlap, right? So we're going to have Republicans here. These are going to be our Republicans. And we know that we are going to put a dot there because some members of the Appropriations Committee are Republicans. Then we go to our second statement. Some Republicans are members of the Ethics Committee. Well, do we know anything about Ethics Committee members also belonging to the Appropriations Committee? It doesn't say anything about that. So what we might do is make another circle over here, say this is the Ethics Committee, and we know that some Republicans are also on the Ethics Committee. So this is what our diagram might look like. Let's look at the conclusion that somebody drew. Some members of the Appropriations Committee are members of the Ethics Committee. Well, here's the Appropriations Committee, and here's the Ethics Committee. Do we know for sure that any of these folks also are here? No, that was an invalid conclusion. Okay, so whoever drew that conclusion used what we call invalid reasoning. Okay, no direct relationship can be established between Appropriations and Ethics Committee members based on these premises. So what I'm hoping that you are seeing is that it's crucial to use this deductive reasoning and logical reasoning, logical steps, not using any other information to draw conclusions other than what you are given.